Here we have two parallel lines, and it's being cut by a transversal is a line that cuts those parallel lines, and it forms a series of angles. And we're going to describe what those angles are and their relationship to each other. Here we have angles A and B, and angle A and B are related to each other in that they're called vertical angles. And vertical angles simply are equal to each other. And there's two sets of vertical angles every time two lines intersect. So here we have C and D are also vertical angles, and these are equal to each other here and here. Now, if these are parallel lines, this transversal also creates a series of angles over here. And when the parallel lines cut by a transversal form these angles, these vertical angles are equal, but C and A are equal to each other, and D and B are equal to each other. Now here we have angle A and B are along this line, and they're cut by the transversal, and A plus B together are going to equal 180 degrees, and that's known as a supplementary angle. Since we've talked about a supplementary angle, I'll just put this in here, but it's unrelated to the parallel lines. When I have a right angle, and then there's an angle made by a single ray here, this angle A and this angle B, this angle over here is equal to 90 degrees. And in this case, angle A and angle B are complementary angles. Complementary angles are angles that add up to 90 degrees. Once I have a single angle that is formed when the transversal cuts into these two parallel lines, I can find every single angle that's here. Since vertical angles are equal to each other, these are both 35 degrees. These two here are equal, so this one's 35 degrees. And then vertical angles, this one here is 35 degrees. Now, in order to get this angle over here, x, I know that 35 degrees plus the unknown angle must equal 180 degrees. So if I did 180 minus 35, I get 145 degrees. Well, again, if I have this 145 degrees, this is a vertical angle, so this is also 145 degrees. But I could have found this by this being a supplementary angle here, where the 145 degrees plus 35 degrees adds up to 180. These here angles, this one here, and this one here are equal, so this is also 145 degrees. And these are vertical angles, these two across here. So this is also 145 degrees. And unrelated to my lesson here, nobody told me that I forgot the S up here. Looking at our parallel lines cut by the transversal, can you imagine that if I was to put another transversal that's parallel to the first, what shape it would make? So here I've added an additional red transversal, and this one is parallel to this one over here. And when I'm looking at these angles here, the same rules will apply. This angle here is equal to this angle here, which is equal to this angle here. And it continues. So all these angles are equal to each other. But now let's just look at the parallelogram all on its own. So here in this parallelogram, this angle over here plus this angle over here must equal 180 degrees when I add them together. Here's why. If I was to extend this transversal, and try to do it best I can here, if I extend the transversals, then this angle over here and this angle over here must be equal to each other. These are called alternate interior angles. And alternate interior angles are equal. And this angle, since this angle here and this angle here are the same, well, this over here being that it's on a straight line, these are supplementary and they add up to 180 degrees. So if we're given a parallelogram and we only have this one angle is 40 degrees, then extending these lines, this angle here and this angle, if there was the vertical angle here, would be 40 degrees. So this angle here and this angle here are equal, so this one must be 40. And I know that these angles, this one here and this one here, must add up to 180, so that makes this one 140 degrees. and it would make this one 140 degrees. So now we have a parallelogram. It's the same one, I'm just changing the angle. If this is 50 degrees, can you find all of the angles on the inside of the parallelogram? Well, this one over here is 50. This angle here and this angle here must add up to 180, so that makes this one 130 degrees. And this one is also 130 degrees. Let's continue our explanation of polygons. And here we have a straight line, and we've formed a triangle with these other two lines here. Now, there's a few consequences of the supplementary angle that we have, and then one thing to remember, because it'll appear later on testing, especially with the SAT and PSAT tests. If I have this angle over here, this is a straight angle, so this is supplementary. These two angles here are going to add up to 180 degrees. And since the three angles inside the triangle add up to 180 degrees, finding this one, which we'll call x, imagine that I have an equation set up where 180 degrees equals the 80 degrees plus 35 degrees plus x. When I add the 85 plus 35 together, I get 115 degrees plus x, and then if I subtract 115 from both sides, I get that the remaining angle, or x over here, is 65 degrees. So if the three angles inside are going to equal 180 degrees, and this angle over here is a supplementary angle that equals 180 degrees, then this one that's outside must be the 115 degree angle, because these two together must add up to 180. Therefore, if you're asked for this angle and you're missing this one, if you add these two together, it's going to equal the outside angle, the 115 degrees. When I have two straight lines that intersect, there's just one more term that we need to know for future problems. So we know that angle A and C are vertical angles, and we know that A and B, they add up to 180. They're called supplementary angles, but angle A and B are also known as adjacent angles. So the angles that are opposite each other are vertical, and the angles that are next to each other are adjacent angles. Adjacent is used in another place inside of trigonometry. So here, if I was talking about angle A, this side over here is the opposite side, and this side over here would be the adjacent side, and this would be the hypotenuse, which is opposite the right angle.